Every software vendor on the market right now is slapping the AI label onto their products. It's created a chaotic environment where finding actual intelligence is harder than ever. That creates a very expensive problem for buyers. You have to figure out if the tool you are looking at is capable of thinking or if it's just very good at moving data from point A to point B. This quadrant chart maps the software landscape. The bottom axis goes from static rules to adaptive learning, and the vertical tracks market hype. Watch advanced analytics and rule-based systems. They have a massive upward trajectory and hype, but remain stuck on the static side. If you buy into the smart marketing without verifying the mechanics underneath, you end up paying a massive premium for a system that still requires your team to do all the heavy manual work. The dividing line between artificial intelligence and everything else comes down to a single metric: adaptability through feedback. Static systems do exactly what they are programmed to do. If you give them an instruction, they follow it perfectly, but they will never deviate from that specific path. Adaptive systems operate differently. They actively refine their own accuracy over time based on the new information they encounter. When you evaluate your tech stack, you are making a deliberate choice between absolute predictability and autonomous adaptability. Getting this right ensures you don't blow your budget on a complex learning algorithm when a simple, well-oiled machine was all you needed to solve your bottleneck. Take advanced analytics. This is a process that digests massive amounts of historical data to uncover past trends. To compare, let's build a tech evaluation matrix looking at analytics, rule-based automation, and AI. For advanced analytics, the core function is generating insights from exclusively historical data. Its adaptability is static. It cannot predict future shifts, meaning human intervention remains high. A weekly sales dashboard will clearly map out last quarter's revenue dips. But if a new competitor enters the market next week, the dashboard won't adjust its forecasts to warn you. Advanced analytics provides a flawless record of what already happened, but it relies entirely on a human operator to look at those numbers and make the actual decisions. Then we have rule-based systems, which also power the majority of what we call smart devices. These tools run on strict if-this, then-that logic. They respond to inputs, but they do not learn. Looking back at our matrix, we can see exactly where rule-based automation fits in. Its core function is execution. It relies on preset triggers to perform specific tasks with flawless repeatability. This is the scripted customer service chatbot that fires off pre-written answers, or the smart thermostat that drops the temperature because you put it on a schedule. The main vulnerability here is rigidity. Adaptability is essentially zero, and human intervention is required anytime those initial rules need updating. If a customer types a question into that chatbot using slang or phrasing that isn't explicitly in the script, the system breaks. It doesn't know how to adapt. Rule-based automation guarantees absolute predictability for the tasks you know about, but leaves you with zero preparation for the unexpected. True artificial intelligence leaves static rules behind. Its defining characteristic is the continuous feedback loop. This flow diagram shows how AI operates. First, it collects data and identifies patterns. Next, it generates new predictions based on the context of the situation. Finally, it autonomously refines its own accuracy based on whether those predictions succeeded or failed, looping that feedback right back into the system. If you buy an AI voice assistant, it might struggle to understand a thick accent on day 1. But by day 30, it perfectly understands the commands because it learned from its mistakes. The trade-off for true AI is clear. You gain powerful, scaling adaptability, but you have to sacrifice absolute predictability and commit to feeding the system a constant stream of high-quality data. With the technical differences sorted, the final step is matching the right technology to your specific operational goals. We generally see two distinct profiles of buyers. First is the efficiency optimizer. They value predictable outcomes, lower operational costs, and strict control over their processes. For tasks like fixed financial reporting or standard customer service workflows, the efficiency optimizer should invest heavily in automation and analytics. The second profile is the strategic scaler. They face operational bottlenecks that require handling high complexity and rapid market shifts. AI isn't a universal upgrade for every business. It is a highly specific tool designed for those who need to scale complex, personalized decision-making. Here is a decision tree to use when evaluating your next software purchase, starting with your primary operational goal. If your goal is strict compliance and predictability, where deviation is a risk, route your budget to rule-based automation. If your goal is understanding past performance to inform human strategy, the correct investment is advanced analytics. And if your goal is scaling personalization and actively predicting future trends, then you need true AI. Keep in mind, a system's ability to answer a question is not intelligence. The ability to learn from that interaction and continuously improve for the next one is what defines true intelligence. Ignore the marketing labels on the box, look at the mechanics inside, and purchase only the precise level of adaptability your bottleneck requires.